Let's look at some quadratic models. If air resistance is neglected, the height s in feet of an object projected directly upward from an initial height of s0 feet with initial velocity v0 feet per second is given by s of t equals negative 16t squared plus v0 t plus s0, where t is the number of seconds after the object is projected. Example 5. A ball is projected directly upward from an initial height of 100 feet and an initial velocity of 80 feet. Give the function to describe the height of the ball in terms of time t. So we'll use the formula and we'll plug in the values that we do know. We know v0 is equal to 80 and we know s0 is equal to 100. And the formula is s of t equals negative 16t squared plus v0 t plus s0. So let's plug in v0, which is 80, and we'll plug in s0, which is 100. S of t equals negative 16t squared plus 80t plus 100. And so here is our equation that describes the position based on the time t. Part B. After how many seconds does the projectile reach its maximum height? From part A, we know the formula for the position is s of t equals negative 16t squared plus 80t plus 100. And this is a parabola that faces down because of that negative symbol. So I know it's a parabola that faces down, and the maximum height is going to occur at the vertex at the point h, k. The time is going to be the x-coordinate, and the output is going to be the maximum height that we're going to get from the function. So we'll need to figure out where the vertex is. We'll use the formula negative b divided by 2a to figure out the x-coordinate of the vertex. So in this case, b is 80 and a is negative 16. So we have negative 80 divided by 2 times negative 16, and using a calculator I get 2.5. So this represents it takes 2.5 seconds to reach the top of the vertex. And in order to find the maximum, we'll plug in 2.5 into the equation. Negative 16t times 2.5 squared plus 80 times 2.5 plus 100. Using a calculator, this simplifies to 200. So the maximum height must be 200 feet, and it reaches that after 2.5 seconds. Part C, for what interval of time is the height of the ball greater than 160 feet? To do this problem, we must solve the quadratic inequality. We'll take our position function, negative 16t squared plus 80t plus 100, and we'll set that greater than 0. And now we have a quadratic to solve, so we'll subtract 160 to both sides. This results in negative 16t squared plus 80t minus 60 is greater than 0. I notice there is a coefficient of 4 that I could pull out of each one, so we're going to divide by negative 4 to every single term, and that of course is going to switch the direction of the sign. So we have 4t squared minus 20t plus 15 is less than 0. By the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, we have the following solution. T equals 5 minus the square root of 10 over 2, and if I use a calculator, I get 0.92. So make sure you use the quadratic formula on your own and get the same numbers that we have here. The first time is 0.92 seconds, and the second time is 4.08 seconds. So please try this on your own with the quadratic formula to make sure you can get these values. So now we have our time is 0.92 seconds and 4.08 seconds. If I draw a picture of what's going on, we have the graph is going to be above 160 feet at two different times. The first time is 0.92 seconds and the second time is 4.08 seconds. So the interval of time for which the graph is greater than 160 feet has to be between 0.92 seconds and 4.08 seconds in interval notation. After how many seconds will the ball hit the ground? To do this, we're going to take our position function s of t and we're going to set it equal to 0. Now we can set our position function negative 16t squared plus 80t plus 100 equal to 0 because we know when the height is 0, the graph hits the ground. And in this case, we have A is negative 16, B is 80, and C is 100. And we can plug that into the quadratic formula. Remember, the quadratic formula in this case is t, because we're talking about time, is negative b plus or minus b squared minus 4ac divided by 2a. So let's plug in these values into the quadratic formula. And we get t equals negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times 100 all over 2 times negative 16. We can type these values into a calculator and we get 2 times. The first time is negative 1.04, which doesn't make sense because you cannot have a negative time. And the second one is 6.04. This represents that it takes 6.04 seconds for the projectile to reach the ground